Is it on? Yeah, okay. I hear now. So I'm Piotr Sarnacki, and I'm Drobus on internet. You can find me on Twitter, on GitHub, on Gmail, and so on. And I will be talking about Travis CI and specifically what's inside Travis CI. I'm from Poland. This is the map of Poland if you haven't seen it already. We are neighbors with Belarus, and actually it makes me very sad that we need all this visa bullshit to go to our countries, but maybe they will cancel it at some point. So let's hope that happens someday. And here's my kind of old photo. And here you see this young, handsome lad. And at some point in time, I changed into this mustached man. I don't wear this mustache because my girlfriend took the razor and cut it off, so I can't do it. And this is because I started working in Travis CI, and there is a small secret that almost no one knows about, that when you work on Travis, you need to have mustache if you want to be higher in hierarchy. So even Konstantin Haze tried to have his mustache at one point in time, but you can see how he looked. Got it off as well. So yeah, Travis CI. I'm sponsored by engineers, so if you appreciate Travis, if you use it, you may thank them on Twitter or whatever. And this is my dream job, so yeah, so many thanks to engineers because I couldn't be here without them. And yeah, let's get back to my presentation now. First, I have a few questions. Please raise your hand if you know what's Travis CI. Okay, quite some people, cool. And please raise your hand if you have any open source projects. Okay, and raise your hand if you test those open source projects on Travis CI. Okay, so that's good. No, a lot of people doesn't know about Travis, so I will be able to introduce you to Travis. And since some of the people don't know it, I will show how it looks like. Okay, let it load. So Travis CI is distributed continuous integration, and it's mainly for open source projects. And it will be for private projects soon because now we are in closed beta. But mainly it's for open source. You can test any open source project there for free. And I love this sentence. This is we are builds for Ruby. We are for builds for what Ruby gems is for libraries. So if you have any library, open source library, you can publish it on Ruby gems. And in the same way, if you have this library, you can test it on Travis CI. So now I will show it to you because okay, so here is how Travis CI looks, and here we have my project, my open source project that I test on Travis on the left. And here we have project view. So let's say that I want to check, for example, Travis artifacts. This is my project that I have on GitHub on Travis CI/Travis artifacts. And I can run my test suite on Travis CI, and here, for example, I have one of the jobs. And here is the output of the test. So Travis CI runs your tests on the cloud, and it can show you the output. It can send you email if the job passes or if it fails. So you may have instant feedback if your tests are good or no. So now when you know what Travis is, let's go. So a few facts about Travis. We run close to 23,000 builds daily, and we have over 5 million builds total. So this is a huge number for me, and I hope that we will soon get to 10 millions because we are growing really fast. And we allow you to test any project in any mainstream language like Ruby, Python, Java, and so on. And even if you program in some esoteric language that we don't support, if you can install it on Linux, you probably could test it anyway because we allow you to run any command line code, so you can just install it on Linux via apt-get. And I noticed that the next presentation is Realny Opit Robotics Jenkins, sorry for harming your language, which to my understanding is a real straightforward experience with Jenkins. I will say a few words about this. Jenkins is, of course, also continuous integration server, but the biggest difference is that Travis CI is not supposed to be run on your single box, for example, on some dedicated server, because we want Travis to be platform, to be infrastructure, so we don't have to set up anything. You just push to GitHub and we build it. You don't need to do any setup. And what's the purpose of this presentation? So Travis CI is open source distributed application, which means that we started to split our monolithic application into smaller apps. And we need to scale. So while we scale, you can watch the entire process, and if we fail, you can learn from our mistakes. So you can go to GitHub, you can check out the code, and you can see what we are doing. And a lot of people talk about service-oriented architectures, and a lot of people talk about distributed applications, but there is not so much information on how those systems actually work in real world. You can see sometimes blog posts, you can maybe see some kind of presentations about it, but you can't usually go to GitHub and see how the code looks like in reality. And running open source application is a bit different than running library. So for example, I contribute to Rails, and if there is a bug in Rails, it's rarely the case when someone will go and if someone sees the bug, it's really the case that someone will go and drop everything and start fixing this bug because it needs to be fixed by tomorrow. It can take weeks or months to fix a bug. And if you run an application and suddenly your application breaks, for example, because the load is too high, you need to make load smaller. For example, optimize or add other slave DB or something like that. So it may be entertaining at times. For example, here is Matthias Meyer, which is part of Travis' team, made a comic history poetry. These are comic messages from Josh Kadirimis, and it's like, I wonder what I am doing wrong with Octopus. Change the required order. I don't think this is the best solution. Hit my head against the wall. And these are comic messages. So he was just trying to fix Travis API, which had really high load, by splitting our DB into master and slave, and he wanted to use Octopus, which is an active record library, to read some of the data from slave to balance load better. And he was like pushing commits to fix it, and he couldn't do it. So yeah, it can be entertaining at times. And I'll start with a bit of history, because it's a nice story of monolithic application turning into nice service-oriented architecture thing. And of course, it all started with Mustache, and it was Sven Fuchs Mustache. And it was Sven Fuchs Travis CI, and this was the only repo that you need to have to run Travis CI. And it worked. The architecture looks something like this. So here we have Travis CI application on Heroku, which listens on GitHub events. And when you push a commit to GitHub, it will notify Travis CI that you pushed the commit, and then it will start building your build. And we had it connected to PostgreSQL database and to Redis, and we used Rescue for queuing. So then when this application got an event, a commit, it pushed information to Redis via Rescue, and then this Travis application on this dedicated box started to build your tests. And it worked. It was good, but there was a big problem. It was one monolithic application, and when you have monolithic application, and especially in a case like this, when this and this is the same application, so you deploy the same code for serving web requests and for running workers, this is not so good, because here we have two concerns. We serve web requests. If you go to Travis CI, our website, we need to prepare a request and show you the web page. And then the same application was dealing with background workers, so it's completely different concern. And there is a few problems, and two biggest ones are growing complexity and growing test suite. And we all probably know, if you worked on monolithic application, you probably know what this means. Suddenly your test suite takes, I don't know, like 20 or minutes or an hour to build, and you no longer run it on your local machine. and complexity is so big that you can't make changes quickly. So the solution was, of course, to split the Travis CI application into two things, and we introduced Travis Worker. So now the situation is a bit similar. We still have Travis CI application listening for GitHub events. It serves web pages to the browser, and it uses Pusher to give updates to the browser, so you can have live updates on the web page. But here is Travis Worker, which is a Ruby application which runs on a dedicated box, and is notified about new builds with Redis, and it just needs to get back to application to send logs, because your test suite will output will have some output, and we want to show you this output on the web page, so we need to push those log updates to back to the application. And it was a great improvement, because suddenly we didn't have one monolithic application, and we didn't have too much mixed concerns, and things were nicely separated. But it was still not the best solution, because if you saw the diagram again, here is the single box, and this is the Travis Worker, and it's just a single box, and it didn't have any virtual machines, so no virtualization. And it meant that you didn't have any clean state after tests. So for example, your test may interact with database or with file system, and after finishing this test suite, you may left some files, or for example, some artifacts in the database like tables or columns. So yeah, those leftovers after tests were a problem, and you couldn't run two builds at one time. So the solution was, of course, to use some kind of virtualization, and we chose VirtualBox. And VirtualBox has a few features, and at the beginning, a few of the best features were that we could have snapshotting. So we didn't use anything like Chef to build worker environment. We just installed Linux on VirtualBox, and then when we made changes, we just did a snapshot, so we can upload it to a worker. And thanks to the fact that we started virtual machine every time before running tests, we have always clean state. We started always from the clean environment. And it was free, which was really nice, because Travis CI didn't have any money at that point. So now the architecture looks almost the same. And by the way, if you have any questions about these diagrams, because they can be later on, there will be more things, you can interrupt me and ask the questions, so feel free to do it. So now the diagram is almost the same. You still have this application serving requests, you still have Redis PostgreSQL, but now this dedicated box can have a few workers. So you can run a few tests concurrently. And again, this was an improvement, but we still didn't have a solution for running a few boxes of Travis Worker. So, and then there was another thing, that there was a lot of coupling still, because if you see this diagram again, if this application, Travis CI, which should only serve requests, if it fails, then you can't run any tests. You will not get any updates from GitHub. You will not push any tests to Redis. So it's silly, right? You want to do some simple change in the UI. You want to change some simple Redis view, and you make a mistake. And for example, maybe you don't have acceptance tests. You forgot about writing tests or something like that, or your tests didn't catch this regression, and now everything fails because of your small change in the UI. And this should not work like this. So the master plan was to use AMQP for messaging, and I will tell what's AMQP in a moment, to create Travis Hub, and I will tell you about Travis Hub in a second as well, and to use JRuby for the worker. And JRuby is nice for things like worker, because as you may know, Ruby can have problems with long-running tasks, because MRI does not have like really good garbage collection. So JRuby is really nice thing to run if you want to run it for days or months without restarting. So why AMQP? AMQP is a message protocol. So we wanted to unify messaging between our applications, because we knew at the point that we will need to split our monolithic application into a few smaller apps. So if you have a few smaller apps, you need to have a communications between them. So AMQP is a protocol for messaging and for queuing. So it's a really good tool for this. So yeah, we wanted to unify messaging. We wanted to send log output through AMQP, because if you send it through HTTP, even if you want to send this small one dot from test output, you will need to send headers and you will need to create new connection. So it will be slow and it will not scale over time. So now we introduced this RabbitMQ, which is AMQP implementation. It's a message queue, so you can send a message to it and then it can route it to other applications. And now we don't have connection from, we have only connection to RabbitMQ from Worker. So here on the left, setup is really similar. You have still GitHub, it pushes events to Travis CI, here you have browser. But now, when we add builds to the database, Travis Hub picks it up, and then it pushes it to the worker through RabbitMQ. And in the same way, when workers have log updates, it will just push them through RabbitMQ to Travis Hub. So we have unified messages between worker and Travis and rest of the Travis CI. So Hub was this central thing that sent pusher updates, notifications, it was creating builds, and getting outputs from the workers. And the biggest advantage of such setup is that when the Rails app fails, we will still run your builds. So so if this is dead, and we have some tests in database, we still can run this part of our architecture. And while you can't maybe see our website on the browser, you will still get your build results after running in Hub. So yeah, this is the main advantages. And the problem is that there were so many changes involved, and doing them at once was maybe not the smartest move ever. And it was 3 months of development, and when we deployed it, there was a lot of firefighting because we introduced AMQP, which was totally new for us. We introduced JRuby, which was also totally new for us. It's still Ruby, but it's on the JVM, so you have different kind of problems there. So yeah, so there was a lot of bugs afterwards, and we were fighting fires. So we learned a very valuable lesson there, that smaller incremental changes are almost always better. And overall, it was great improvement. Although the execution was not that great, it was great improvement in our architecture again. But still, there are things that could be improved. So if you look at this again, we decoupled Travis Hub. So now this part of architecture can work without without this part. But still, if this fails, you can see that GitHub is connected to it. GitHub events go to this Travis application. So again, it's still a thing, right? If you have small UI update and this application fails because of that, you will not get any updates from GitHub, and this is bad. So the solution was to create Travis Listener, and the only purpose of Travis Listener was to listen to GitHub events. So now, here is our Travis CI application. It still serves web pages to the browser, but now Travis Listener is here and it's only listening to GitHub events, and it's saving into the database, and it's pushing information to RabbitMQ to notify other apps in that particular moment. It was only Travis Hub about new builds. So now, even if the Travis CI application in Heroku fails, we will still get events from GitHub, and this is very important because if we can save event about build in the database, even if this thing fails, we have it stored in the database so we can run it later, even if something queue fails. Yeah, so just like I said. And now, when you look at that, you probably can see one more issue with this. Here is the connection to the database, and here is the connection to our queuing system. So we have two connections with Travis Listener, and since it's so crucial element of our architecture, it's silly because when database will be dead for some reason, for example, you run some really long migration, then you will not get any events from GitHub because it will fail to save them to database. So we remove this thing, And now this is a lot simpler because here we have GitHub events going to Travis listener, and Travis listener pushes it to RabbitMQ, and then Travis Hub is saving them in database. And of course, RabbitMQ can still fail, and then you will not get events, but it's not so likely as database, because database can, for example, fail because of high load, which can happen if you have, for example, a lot of traffic on your website, or it can fail because you run really long migration. And RabbitMQ is just a messaging system, so it fails not so often. And also another thing is that if, for example, for some reason Travis Hub can't save the build in the database, it will not send confirmation to RabbitMQ, and RabbitMQ will not remove the message. So it will have this message until Travis Hub saves it somewhere. So it means better reliability, and it means also easier deployments, because and rare changes. Because I checked yesterday when was the last deploy of Travis Listener, and it was almost exactly a year ago, a year and a few days. So it means that through all the time, through all the entire year where Travis CI is changing rapidly, we didn't have to do any changes in Travis Listener, and we didn't have to deploy this application because it was doing only one thing, and it was doing this thing good. And that all means that we have small chance of losing events from GitHub. And it's great, right? But of course we can still things that we can improve. And the next thing to improve was that Travis Hub did a lot of things. So it was sending confirmations, it was sending notifications to email, it was sending notifications to Campfire, it was sending pusher updates, and it was doing much more things. So it was not good because, as I said, if application is doing a lot of things, the test grows, complexity grows, and then if you want to change, for example, how your email notification works, you can break Travis Hub, and then you don't have any builds because you wanted to change just a small thing in emails. So we split Travis Hub into 3 applications. So here you can see that this diagram is almost the same, but now instead of one application here in Travis, instead of just Travis Hub, we have Travis Hub, Travis Logs, and Travis Tasks. And these are simple applications. Travis Logs is a simple application that just takes messages from RabbitMQ, log updates, and it saves it to the database. And Travis Tasks takes messages from RabbitMQ about finished builds, and it sends, for example, email notifications, it sends Campfire notifications, and so on. Some things that are not so crucial for running the app. So if it fails, it's not as big deal as when Travis Hub fails. And it's great improvement again. But of course, there are still things that we can improve. So the next thing that we spotted is that API was coupled with the client. So we have this API that everybody can use. For example, you can build your own mobile application that uses API, or your own command line client that uses API. And we had also the browser client running on the same host. And this is bad because then, while you are doing changes to the UI, to the browser client, you may break the API, which is used by a lot of other clients. So you will break API for everyone. So we decided to split Travis CI application into Travis Web, which is Ember.js JavaScript client, and Travis API, which is a simple Sinatra application, which just serves API requests. And this is good because API does not change that often. We try to keep API stable. And on the contrary, Travis Web changes quite often because we need to make fixes for different browsers. We need to make some CSS, sometimes maybe improvements, and so on. So it means easier deploys because we don't risk breaking API with every Travis Web deploy. And the only problem was that we had separate domains for API and Travis Web. So we used CORS. And how many of you know what CORS is? Okay, so I will explain. So CORS is cross-origin resource sharing. So if you write your application in JavaScript, if you want to make AJAX request which goes to the other domain, you can't do it without. You can't do it in normal circumstances. And CORS, which is a technology which is supported by modern browsers, let you do just this. It allows you to make AJAX requests to other domains. So our API sits at api.travis.ci.org, and our application sits on travis.ci.org, and we can send AJAX requests from one domain to the other. So it means that our API and the client can be nicely isolated. And all the things that I tell you about right now here are called service-oriented architectures. And it means that you have a lot of small apps that communicate with each other. And the benefits are better reliability, because if you break one of the apps, it doesn't mean that your entire thing breaks. And it means better scalability, because if you have those small applications, like if, for example, log processing is slow, if I get back to this last diagram, if this thing is slow, we can just make more instances of Travis logs. We don't need to make more instances of one big monolithic application. Yes, so. And it means better maintainability, because we have smaller applications that does less things. We have smaller test suite, and we can maintain it better. There are of course some drawbacks. Like, for example, there is more applications to change. So if you want to make a feature, you need to think more about this, because maybe you need to make changes in 2 or 3 apps in the same time. And that means a bit more overhead, because you no longer go to one code base and rush with the change quickly. And also, distributed computing is hard. So while you have all these drawbacks, you need to plan really well to make your architecture, to design your architecture in a way that is reliable and fast, and in a way that it doesn't break. So we went from one big monolithic application to service-oriented architecture, but it's not that we are so awesome. We can always do better. We can always fix some things. So can you spot the problem on this diagram? Who sees a problem with this?
One dedicated box.
Sorry?
One dedicated box for all workers.
No, sorry, I haven't mentioned it, but now in the step when we added the AMQP, we also allowed to have a lot of these boxes. I should probably add here some number that it can be more than one box. Okay, so for me the biggest problem here is that there is a lot of sharing here. So if you have this diagram, you see that all those applications need to talk to database, and all those applications need to talk to RabbitMQ messaging. So if this fails, or if this fails, we will have most of our architecture broken. So next step would be probably to remove all that coupling and go towards more well-defined public APIs, which we can maintain easier. And our code sharing is not that optimal. You will not see this in the diagram, but we have Travis Core repository, which other repositories rely on. So in Travis Core we have our models, we have our code for notifications, we have other parts of code. And this is kind of bad, because if every application just relies on one big library, then your history may look like this. I don't know if you can read it, but all the messages, except this one, are saying bump Travis Core. So this is like bump Travis Core, bump Travis Core, bump Travis Core. And this is bad because this is Travis Hub repository. And this is very bad because now we have a history of Travis Hub changes, and actually we don't see what changes here. We just bump Travis Core in the gem file, and we can see that if you go to any of these commits, you can see that SHA of Travis Core changes from one to the other. But what was the change? Why did I bump Travis Core here and then bump Travis Core 2 weeks later? I don't know. I would need to see the difference between those commits in Travis Core, and then I could tell you, but this is a very bad thing. So the next step would be also probably to split Travis Core to get the concerns to the applications where it belongs. Yeah, this will be then our next step, but this is not that easy because when we go from one monolithic application, we can't just split everything at once, and we like to do smaller changes, so this will take probably some more time. And to the end of my presentation, I have a few tips. If you want to go with this route of distributed applications, there is a few things that you can avoid. And so first tip is to make small changes. Don't make big changes because you will have a lot of errors and you will have a lot of firefighting, and it will be harder to see what's going on. If you do just one small change, you know what was broken probably because you knew that you did only one thing. And also you need to have good metrics, because now this is not only one application that you can SSH into the one server and you can see statistics and you can see what's going on, but now you have a lot of applications talking to each other, so you should have something like this. We use Libretto metrics, and these are metrics that show us, for example, how many RabbitMQ messages are at the moment and how many active builds there is per queue, how many builds are waiting. So, for example, if people are saying that we don't run builds and something is broken, I can go to this dashboard and I can see which of these charts look odd, and usually I can immediately see what's the problem. So it's good to have good metrics. You should also not break public APIs. You should keep them. You should keep them solid. You should keep regression test suite to make sure that you don't break anything. And if you need to break, if you totally need to break, you should deprecate first. So you can never be sure if no one is using the API. So before removing a feature, you should probably add some warning and when someone uses it. And when you are totally sure that no one uses it, then you can remove it. And you should always keep deployable master, and it's important in every application probably, but if you have so many applications, it's hard to communicate through in the team who wants to deploy what. So if any of the applications is broken and someone will deploy it, it can break your entire architecture, so it's especially important when you work with service-oriented architectures. And to do all the things that I mentioned, so to don't break APIs, you can use something like feature flips. So for example, if you make new feature and you need to deploy, for example, 2 or 3 applications and you need to remove something, you can add feature flips. So you can add something like, we have Travis Features class, which uses Redis to store information, and you can check if feature foo is active. And if it's active, you can do the thing. So that way, you can first deploy applications, and then you can enable the feature. And also, you should keep database changes bulletproof. So, for example, I needed to add column to builds table. This is the table where we store builds. And I need to do it because we kept branch column on commits table. And whenever we wanted to get builds from, for example, master branch, we needed to join with commits and then look for master branch. And it was slow because joins are slow if you have a lot of records and if it's used often. So I added this branch column to builds table, and now I can use it, but only if builds column names include branch. So first I check if this migration was run, and then if it was run, I use this code, and if it was not, I use regular join. So that way you can be sure that your code will not fail when your migrations does not run, or if some of the applications is not updated. And the last thing is Google for fallacies of distributed computing, because there is a few things that if you begin to do distributed applications, you can have some misconceptions, like you are maybe accustomed that that every message will get delivered, and if you split applications, suddenly the network, there can be a network failure, or there can be timeout or something like that, and you no longer get the message. So if you know those fallacies, it's easier to plan and to architect your applications. And that was about it, so thank you. Any questions? Do I have time for questions?
Thank you, great job. I have a question. Is it possible to use my special environment for running tests on my application?
So it depends on the environment, because you can't upload your entire virtual machine, but you can run any Linux command. So if your environment does not need downloading half of the internet to the machine, then you could probably just install the packages. So for example, if you need some, I don't know, like some Java libraries, you can probably download it with Maven, or if you need, for example, some Linux library, you can install it via apt-get. So it mostly depends on how much do you need to download. And if it's something that is common, you can just write us an email and we may just include it in our machines. So there is a possibility.
Thank you. Еще вопросы, ребят? Thank you. Why did you choose RabbitMQ? Because so many MQ providers.
Yeah, so this is a good question. We chose RabbitMQ because it's solid. It has the RabbitMQ is running on AMQP protocol, as I mentioned, and the big disadvantage of this protocol is that it's very complicated. So there is a lot of libraries for AMQP, and it may get complicated because one library, for example, client library, may have different protocol version than the server, and it may be hard to match them. So these are problems of AMQP, but after all, it's one of the mature and good solutions that you can use. So we decided that while it has its disadvantages, it's a good solution for our needs, and maybe we'll migrate some of the things from RabbitMQ to the other solution. But at the point, it was the easiest thing that we could do, because yes, there are simplest solutions, but they are not so popular as AMQP and RabbitMQ. So, and we had so also I forgot about this one. The really good thing about using AMQP, because we had Michael Klishin in the team at that point. So it was very good because he was in core team. He was maintaining a few AMQP libraries. So he had the knowledge how to set up it in a good way. So yeah. So if you know any other messaging protocols or messaging software, and if you are accustomed to it, you should probably use it. But if you have someone who knows AMQP and it fits your needs, then it's a good solution.
Thank you for the job, and I have one question. You mentioned that one of the next steps in the development is to add support of private repositories.
Yeah.
And did you mean private repositories only on GitHub or on any other server?
Yeah, so at this point it's only on GitHub, because our infrastructure is built on GitHub events, so we can get only events on GitHub, but we want to change it in the future. We want to add Bitbucket or maybe some other providers, but I can't give you any ETA, or I can't say how soon it will be, because I don't know. So if you are not using GitHub, you will need to wait probably, or move to GitHub.
I know, but there are several company policies, security or something like that.
Yes. So yeah, that's also a problem. So if you keep your Git repositories so we will probably at some point offer running repositories from your private Git from your private server. But the problem is that we will need to change a lot of parts in our architecture. So while it will happen at some point, it's not our priority, because yes, it's sad that we left companies that doesn't use GitHub, but we don't have we have a team only of 5 people, and Travis CI is getting larger and larger, and we need to support open source projects as well as private projects. So I can say that it will probably not happen soon. It will happen at some point in time, but it's not a priority at the moment.
You have insight on the Travis CI Pro going to release it.
Yeah, so if you want to use Travis Pro, you can shoot me an email on drogus@gmail.com or to support at travisci.com, and maybe you can put it up for you.
Cool. I will do. Thank you.
Thank you, bro. We appreciate.